Okay, good day. Today we're going to discuss Module 4 of CE 2121, Measurements of Angles and Directions. So to start off, we define what is a meridian. To begin with, we define a meridian, which is an imaginary great circle on the Earth's surface, passing through the geographic poles of Earth. It is a reference line which is considered to be 0 degrees. There are 4 types of meridians: the true meridian, magnetic meridian, grid meridian, and your assumed meridians. So the primary reference line we have at 0 degrees is what we call your prime meridian, which is located at Greenwich, England. So for a true meridian, this is also known as your astronomic meridian or geographic meridian. This is an imaginary line passing through the geographic north and south poles of Earth at any point on the surface of Earth. So if we have here a line that defines the axis of rotation of Earth, so this is your south pole, this is your north pole. So any line passing through your north pole and your south pole is your true meridian or your geographic meridian. So next we have magnetic meridian, which is a fixed line of reference which lies parallel with the magnetic lines of force of the Earth. Its direction is defined by a freely suspended and balanced magnetic needle of a compass. So in comparison with the true meridian, this is now our magnetic meridians. So this will be defined, or its direction will be defined by our compass. So it would vary depending on the force of, or the magnetic force of Earth. So any line that would pass through your magnetic north and magnetic south pole will be your magnetic meridians. So next we have the grid meridian, which is a fixed line of reference parallel to the central meridian of a system of a plane rectangular coordinates. It is limited to plane surveys and is usually used for mapping. So in comparison to our true meridians, so we will now be using the true shape of the Earth, which is elliptical. So we have here your central meridian or the prime meridian. So all our grid lines or grid meridians, so all the grid meridians are parallel to this central meridian. So it will be at equal intervals also. It's the line that we see in our maps. So the difference in your true meridians and the grid meridians are usually neglected since it is very small. So lastly, we have your assumed meridian or that arbitrary meridian, which is any direction assigned to some line in the survey from which all other lines are reference. An example would include a line between two property monuments, a center line of a tangent piece of roadway, and the like. So this have no any relation to any other meridians. Unlike the 3 meridians that we have discussed, this one will not be related to our true meridians, magnetic, or your grid meridian. We have units of measurement for angles. So a review, we have the sexagesimal system, which is measured in degrees, minutes, and seconds. So this will be our measurements. So we have for the north, we have either 0 or 360 degrees. Our east is at 90 degrees. South is at 180 degrees. And west is at 270 degrees. Another unit is from circular system, which is measured in radians. So the equivalent of radians to your sexagesimal system will be in terms of your pi. So 1 revolution is equivalent to 360 degree, equal to 2 pi radians. Another unit for measurement is from your centesimal system, which is measured in your grad or gradients. So this is your measurement of angles, at which we defined a 90 degree angle is equivalent to 100 gradients. So therefore, for our measurements, the 0 degree is the same as our 400 degree or 400 gradients. At 90 degree angle is equivalent to 100 gradients. At 180 degrees is equivalent to 200 gradients. 270 degrees is equal to 300 gradients. And lastly, we have a derived unit from the metric system or from our circular system, which is our mils or called milliradians. This is defined as 1 of 1,000 of a radians. So its equivalent now will be for 0 degrees, it will be equivalent to 6,000 or 0 to 6,400 mils. 90 degrees is equivalent to 1,600 mils. 270 degrees is 3,200 mils. And for the 270 degrees is equal to 4,800 mils. So 1 revolution is equivalent to 400 grad and is also equal to 6,400 mils. So please do remember this unit conversion for our angle measurements. So we have the designation of our north point. Since we have 4 types of meridians, we will also have 4 designations for our north. The first is our true north, which is the north point of the true meridian and is always shown along a vertical line. The magnetic north is the north point of our magnetic meridian, which may be located to the west or east of our true north. And our grid north is the north point established by lines on a map parallel to the central north. And the assumed north is a portrait of an arbitrary location of your north point. So for the true north, this will be designated as a star. Our magnetic north will be designated by half arrow. And then we have your grid north designated by a full arrow. And lastly, we have your arbitrary north designated by a point or a circle. This is the relationship between our true meridian and our magnetic meridian. This is computed as the difference of the true meridian and your magnetic meridian. So this is our true meridian. This is our magnetic meridian. So the difference in angle is what we call your magnetic declination. symbolized by the Greek letter delta. So a positive magnetic declination means that our magnetic north is on the right side or on the east side of your true north. So to understand further magnetic declination, let's say we have here your true north and your magnetic north. So let's have line A to be measured. So the angle between the true north and line A is your true bearing, and the angle between your magnetic north and line A is your magnetic bearing. As we have said, the angle between your true north and your magnetic north is your magnetic declination, in which a positive declination means that the magnetic north is on the right side or to the east of our true north, and a negative, so a positive declination is to be subtracted from the true bearing in order to achieve our magnetic bearing. A negative declination means our magnetic north is to the left side or the west of the true north, and it is to be added to the true bearing to obtain our magnetic bearing. So remember, positive declination is to the right and has to be subtracted. Negative declination is to the left and has to be added. As an example, in an old survey, magnetic bearing of a line was recorded as north 35 degrees 15 minutes east. The declination at this time was 2 degrees 10 minutes west. At present, the declination at the same locality is 3 degrees 15 minutes east. Determine the true bearing of the line and the present magnetic bearing to be used in retracing the line. So in order to solve this problem, we have to draw our true north with the magnetic north of the pass at 2 degrees 10 minutes west, and the magnetic bearing at this time is at north 35 degrees 15 minutes east. So at present, we have our declination at 3 degrees 15 minutes. So our equation now for magnetic bearing is equal to the true bearing plus or minus your declination. So again, we add your declination if it's towards the west, and we subtract if the declination is towards the east. So for our magnetic bearing for the pass, it's equal to the true bearing plus the declination of pass, since it is to the west. So we have north 35 degrees 15 minutes east is equal to the true bearing plus 2 degrees 10 minutes, or the true bearing now of the line is north 33 degrees 5 minutes east. We will use the same equation for the magnetic bearing of present. So plus or minus the declination. For this, we are going to subtract now our declination as it is moving to the east. Magnetic bearing of present is equal to the computed true bearing minus 3 degrees 15 minutes, or the magnetic bearing at present is equal to north 29 degrees 50 minutes east. So next we have the direction of our lines. This is defined as the horizontal angle between the measured line and established line of reference. So we have different ways of defining our direction of lines. So we use our interior angles, deflection angles, angles to the right, our bearings, in which we have your forward and backward bearing, and lastly we have the azimuths, which will also have their forward and backward azimuths. So as a review, interior angles are the angles inside a closed polygon or a closed traverse. They are measured either clockwise or counterclockwise. As a check, the interior angles or the sum of the interior angles should be equal to n minus 2 times 180 degrees, at which n is equal to the number of sides. So if we have here your polygon or traverse, so the angles inside are your interior angles. So next we have your deflection angles, which are horizontal angles measured from the extension of the preceding line to the next line. So if our rotation or if our measurement is clockwise, we consider the angle as to the right, and if our measurement is counterclockwise, then our value is considered to the left. So from the series of lines, we can identify our deflection angles. So for line 1, its extension will have a counterclockwise angle, so it is a deflection to the left. For line 2, its extension is, or from the extension, it will have a clockwise measurement, so it is to the right. Line 3 will have a right deflection angle, and line 4 will have a left deflection angle. Next, we have angles to the right. So these are angles measured clockwise from the preceding line to the succeeding line. So in one in line 2, this one, 2 to 3, and 3 to 4. So next we have your bearings, which are the acute horizontal angle between the reference meridian and the line measured or laid out. If we have here your geographic quadrants, your north, east, south, and west. So the reference meridian is our north-south line, and the reference parallel will be your east-west line. So to understand bearings, let's have an example. So we determine now the bearings of the given lines A, B, and C. So for line A, its bearing now will be south 67 degrees 30 minutes east. So that is measured from south to east. Next we have line B, which will be north 45 degrees 15 minutes west, meaning from north we have 45 degrees 15 minutes going to the west. And for line C, this could be written simply as due west or north 90 degrees west. So for our forward bearings, these are now defined as the bearing of a line observed in the same direction of our survey. For backward bearings, these are bearing of lines observed in the opposite direction of the survey. So if we will have points 1 and 2, the forward bearing now is theta at 1, and the backward reading is for theta at 2. Take the lines made by the series of points A, B, C, D, and E. So the forward bearings and backward bearings of the lines formed will be for line AB. It is north 49 degrees 27 east. BC is south 38 degrees 35 minutes east. Line CD is north 88 degrees 1 minute east. Line DE will have a forward bearing of north 42 degrees 40 minutes east. The backward bearings will be measured from point E back to point A. So for line AB, we'll have 49 degrees south, 49 degrees 27 minutes west. BC is north 38 degrees 35 minutes west. CD is south 88 degrees west. Line DE is north 42 degrees 40 minutes east. So as you can observe, the forward bearings and the backward bearings will have the same angle but will have opposite in direction. So next we have your azimuths, which are the angle between the meridian and the line measured clockwise. So it should be measured from either north or your south. So for example, we have here your Cartesian plane, geographic Cartesian plane. So if we will take the azimuth from the north for line A, it will be from the north clockwise until our line. So this line will also have from the north clockwise to the line. Azimuth from the south will have to measure it from south clockwise. So to give us an example, let's take lines A, B, and C. So we take the azimuth from the north for line A. It will be 90 plus 30 degrees 58 minutes, which is 120 degree 58 minutes. For line B is 270 plus 36 degrees 39 minutes, or that's 323 degrees plus 21 minutes. Line C, we have 270 degrees. For azimuth from south, we will have 270 plus 30 degree 58 minutes, 300 degree 58 minutes. Line B, we will have 90 or 180 minus 36 degrees 39 minutes, 143 degree 21 minutes. And line C is 90 degrees. So we have the forward and backward azimuths. Same idea as for forward and backward bearings. Forward azimuths would give the forward direction of the line, and backward azimuths would give the reverse direction of our line. So example, we have your points 1 and 2. Forward azimuths are taken from point 1. So we have your azimuth from the south and azimuth from the north. And then next, we have your backward azimuth taken from north and south at point 2. So take note that if our forward azimuth is less than 180 degrees, we add a 180 degrees to obtain our backward azimuth. And if we have a forward azimuth greater than 180, we subtract 180 degrees to obtain the backward azimuth. As an example for forward and backward azimuths, let's take the series of lines created by points A, B, C, and D. So we will have your forward azimuth and backward azimuths from the north and south. So for line AB, forward azimuth from north, 141 degrees, 25 minutes. BC will be this angle, 88 degrees, 1 minute. And line CD will be this angle, 42 degrees, 42 minutes. Forward azimuth from south for line AB. So from south to this line, we'll have 321 degree, 25 minutes. For line BC, from south to BC, we'll have 268 degree, 1 minute. And line CD will have this angle equal to 222 degree, 42 minutes. So for our back azimuth from the north, so FA is less than 180, you add 180, will arrive at 321 degrees, 25 minutes. Line BC, less than 180 is its forward azimuth, so we add again 180 degrees, will arrive at 268 degrees, 1 minute. And for CD, it will be 222 degrees, 42 minutes. If it's from the south, the back azimuth for lines AB, BC, and CD are all greater than 180, so we subtract 180 degrees. So we'll have 141 degrees for AB, BC will have 88 degrees, and CD will have 42 degrees, 42 minutes. So if you're going to observe, the backward azimuth of lines from the north will be its azimuth from the. So thank you for listening. For your evaluate activity, please answer the following questions. For your reference, you can check this book and website.